Hi there. In this section, we're gonna start wrapping things up for our big series of platformer videos. I can hear you're cheering through the computer. Maybe that's my own cheering because we're getting close to the end. The first thing we're going to do in this section is we're going to give our player some Mario-esque powers to be able to destroy the enemy by landing on top of its head from above. And we're going to give our enemy the ability to cause some injury to our player by walking into the player. So let's open up the player object and let's add a collision event with the enemy. And what do we want to do inside this collision? Let's start with the Mario piece of this. All right? In order for that to work, we need to know a couple of things. We need to know if when the player and the enemy collide, if the player is colliding from above the enemy. And to be on the safe side, we also need to know if the player is falling, meaning the player is moving down screen from the top toward the bottom. And only if both of those things are true, then we will give our player Mario powers, then they'll be able to then destroy the enemy. So how can we pull that off? Well, to check if the player is colliding with the enemy from above, let's create a local variable using the keyword var, and we'll set the name of the local variable to above enemy. Now, how can we use that variable to store like a true or false piece of information about whether or not the player is above the enemy? Well, we can do this. We can say if y, meaning the player's y, is less than the other y, meaning the enemy's y, and just to be safe, we'll add a little bit of vertical speed to that other player's y. That will make essentially it makes sure that since we have set our origin point in the center of these objects, we want to make sure that it's sort of above the, actually really truly above it, so I'm just adding the vertical speed to that to give us a little extra space. Okay, if that's the case, well, that would mean that the player is above the enemy, right? So we could say if that is the case, then above enemy equals true. All right, else above enemy equals false. There is a nice shorthand way to say this same thing with less typing. So let me comment this out for a second, and let's make use of a little nifty shorthand to do the same thing. And we can do it up here when we first declare this local variable called above enemy. We can set it equal to the player's y, and then we'll say less than the enemy's y plus VSP, the player's VSP. This line, this big old long line with the if statement, and this line are functionally the same thing. What this is, when we say y less than other y plus VSP, this is essentially a check. We're saying, is this true? Is the player's y less than the enemy's y plus the vertical speed of the player? If that's true, we'll store the value true inside above enemy. If it's false, we'll store the value for false inside above enemy. Or I should say, if it's true, we'll store the number 1. If it's false, we'll store the number 0 there. Okay? So let's use that shorthand. I like that. Similarly, let's create a local variable for checking if the player is falling down onto the enemy. Well, in fact, we'll call it falling. And we'll do a similar idea. We're going to say, is the vertical speed of the player greater than 0? And if that's the case, this is checking. Is the vertical speed greater than 0? If yes, then falling is true. If no, then falling is false. Remember that vertical speed, if it's a positive number, is being used to say that an object is falling from the top of the screen towards the bottom of the screen. Okay, Let's make use of these two checks now and then perform actions if they are both true. So we can say if above enemy is true, that's what the implication is, and falling, again, is true, even though we don't explicitly state that. What do we want to do? Well, we want to kill the enemy. So a quick way to kill the enemy is we can say with other, meaning now we're talking to the enemy, HP equals 0. Remember that each enemy object has its own hit points, and every time it's hit by a bullet, those hit points get decreased by 1, and when the hit points reach 0, we instantiate the dead enemy, and we basically kill the enemy. So by instantly setting the hit points to 0, we are killing the enemy. Else, what if we're not above the enemy and falling? Then what do we want to do? Well, in that case, we want to let the enemy injure the player. It means the player has walked right into the enemy. So we'll say be hurt by enemy. And we can pull that off pretty easily. We set up a player health variable on the player a long time ago. And so we will decrease the value of the player health by 1. Now the way this is going to work is like the Evil Clutches game, where we had like the demons that would collide with the dragon mother, and then they would lose all their health because they continued to collide all the way as they moved through the player. Similarly here, when the enemy collides with the player, it's going to keep on walking, right? Colliding with it, colliding with it, colliding with it, moving right through the player. And the entire time that the two of them are overlapping, the player's health is going to continue to drop. And so we'll let that happen. It will be a way of causing damage and encouraging the player to get out of the way of the enemy. But we'll only drop it by 1 so that they don't lose a ton of health, because it's going to continue to lose health, right? As long as they overlap. What else do we want to do? Let's give some nice sound effect to the player, letting the human player know that the computer player is being hurt. So we do our usual audio play sound. SN pain is the name of the sound. We'll set the priority to 10 as always, and we don't want it to loop, so we say false. Now right now this is going to cause us a problem, and let me show you what it is, and we'll do a quick fix of it here in a second. Alright, here we are. Watch what happens when I get hit. I'm not entirely sure if you can hear that or not. Here, I can jump on him though. Ha! And kill him off. So the Mario-esque part of this works just fine. But there's one small problem when the player collides with the enemy from the side. And that's with the sound. We hear a series of the sounds being played over and over and over and over and over and over and over really quickly. It's the same issue, really, that we had in the Evil Clutches game, because it's continuing to collide, it's continuing to play the sound over and over and over and over again, so we don't want that to happen. So we're going to say if not audio is playing, which sound? SN pain. So we want to check, is the pain sound playing? If it's not, play the sound. If it is, don't play the sound. That's what this line of code does right here. That way we can make sure that the full sound for the pain plays all the way through before another one starts. So you might get a couple. As you can hear, if I cruise along with him, I'll get a whole bunch. Take that! And then I can jump on him from above. And that's it. So we've implemented both the Mario attack and the ability for the player to be hurt by the enemy. So what's left in our big roundup of finishing touches on this platformer game? Well, one thing we really want to take care of that I probably could have done earlier is that you'll notice that when we play the game, we are kind of zoomed out pretty far on our player. And in a typical platformer game, it's much more likely that you will have the camera zoomed in on the player and that the camera will follow along with the player as the player works his way or her way through a really big room. So let's take care of that section next. To really make this work nicely, I want to go back into my first room here, and I want to change the size of the room, and I'm going to make the room much longer, or I guess I should say much wider, just so it makes more sense to have this kind of thing working inside the room. So if you look over at the room 0 and you look over at the properties, come down to the room settings, you'll see that right now the width of the room is 124 and the height is 728. Let's make this room way bigger. Okay? So I'm going to set the width of the room to 2048, and I'm going to set the height of the room to 1024. Right? Then, good grief, now it's huge. So let's see. Now when I do that, you'll see now we've got our little platformer stuff is sitting way up here in the corner, which is not really where we want it. And so I want to redesign the whole layout of my room so that we can sort of make use of a zoomed in view of our player. I'm not going to do this in the video, but I want you to go ahead and do it. You can attempt to move around the ones that you've already got, but I actually think it's probably easier just to redesign the entire level. So use your auto tiling tool to draw out a nice level that stretches all the way across the room. Excuse me, and then put wall objects around the floor and the wall, and then reposition the player and your enemies. Do all of that and then come back to the video and we'll continue from there. Okay, you get your room redesigned and reset. Here's mine. It's not super pretty, but I've just layered out some tile sets and put some walls, repositioned some enemies, added in a couple of extras in here. Use the enemy barrier in a couple places to help my guys patrol. All right, so wonderful. But if I actually play this now, which I'm not even going to do in the video because my dimensions of my video are much smaller now than the dimensions of the room, what you're going to see is this huge, wide window on your computer with this tiny little player stuck in the corner of it. So that is not what we want this to look like. So to fix that, we're going to make use of cameras. And here's how we can make that work. So let's stay here in our room for just a second. And if you go down on the room properties and scroll down, you'll find a section called viewports and cameras. And if you extend that out, here's where we can start to set things up. We're going to click Enable Viewports, and that will allow us to use, just like it says, a viewport, although we're going to do a kind of a camera version of a viewport. Open up Viewport 0, and under Viewport 0, click Visible. And when you do that, you're going to see now we have this section of screen out here that is a surrounding part of the room, and its default width and height will be 1024 by 768. We don't need to even do anything with the rest of this because we're going to set it all up using a camera object. So just do that. Enable viewports, open up port 0, and click Visible. Okay. Let's close out our room and let's create a new object. We'll call this object O Camera. Our camera doesn't need a sprite, it just needs some events and actions so that it will work. So let's add, oops, not a destroy event, good grief. Let's add a create event. And then we're going to set up a collection of custom instance variables that we'll make use of in order to be able to zoom in to a specific part of the room and to also follow the player. All right. We're going to create one custom instance variable that we'll call cam. And into this, we're going to pass a reference to that viewpoint 0 that we just set up a second ago. So we're going to say view camera 0. Okay, so this is going to just pass us an ID for the viewport that we just set up. It's also a camera, right? And store that here in this cam variable. We're going to set up something else here called follow, and we will pass it a reference to our player object. The idea here is that we want to set up the camera and have that camera move along with the player, keeping the player sort of centered in the middle of the camera. Now we could just directly say, when we set up the code for this, follow the player, and the camera will follow the player. But by setting up a custom instance variable called follow, we could conceivably change what the camera follows. If for some reason we wanted, for example, to follow an enemy, we could change follow to be the enemy. Now we might run into some issues with that because we've got lots of different enemies and we only have one player. So when GameMaker is trying to follow an enemy, but you've got a bunch of enemy instances, what it will do is, I think, follow the most recently created version of the enemy object in the room. All right, we may have heard the phone in the background there, but I'm back. So in our case, we're really just going to follow the player, but we're sort of setting this up just in case you wanted to have the camera follow something else. All right, we also are going to create another custom instance variable called buff or buffer. And this is going to be the number of pixels that we want sort of around the player. I'll show you how we use this. Then, coming back to the idea of how we want this camera to work, we want the camera to zoom in into the room, and we want it to follow the player, or the follow object, with that object centered in the middle of the screen. So how do we accomplish the centering of the player into the middle of the camera? Well, let's create another custom variable called view w half. And let's set this view w half equal to camera get view width. This is a built-in function. We need to tell it which camera to follow, and we'll tell it to follow the camera that we just set up. And we'll multiply that by 0.5. So what that is going to do is going to find out what's the width of the camera that exists currently, and basically divide it by 2. You could have actually said divide by 2, but it's the same idea, multiply by half. So if I go back into my room here, you'll see that here is the camera, right? This is the camera for, we come down to viewports and cameras, you'll see we've got enable viewports, we open up viewport 0, and then you see it is effectively a camera, and its width is 1024 by 768. So this is going to give us half of that 1024, basically. Let's copy that, paste it in, and we'll call this one view h half. And we will store in that camera get view height, another built-in function that will figure out what the height is of the camera that we pass it, and then we'll divide that by 2, or I guess I should say we'll multiply it by half. And by this, what we're getting now is going to be an x coordinate that's in the middle of the screen and a y coordinate that's in the middle of the screen. Okay? Finally, we're going to set up it's sort of like we create our own custom horizontal speed and vertical speed. We're going to set up our own custom version of x and y coordinates. And we're going to call it x2, which is going to be the position we want the camera to move to. And we'll just initialize it to x. It doesn't actually matter. You can initialize it to 0. You can initialize it to whatever you like. And y2 equals y. And this will just be set up wherever, again, we've got the camera, wherever it happens to be when we first place it out in the room. That's what it will be set to. Okay? All right, so these are all the things we need to get things going. Now let's take all of this information and make use of it in order to have the camera zoom in and follow the player. So let's do a create event, a step event, and we'll use the step event to update the camera. In fact, I'll say that, update camera. So what do we want to do? First, we want to make sure we're going to have the camera view following the player, in our case, but following whatever object we have stored in our follow variable. So if for some reason that object is not in the room, we would get an error. So we need to do a little safety check here to make sure that whatever we're following actually exists in the room so that we don't run into an error. So we'll say if instance exists, and we've used this before when we did the koala game as a way of moving from one room to the next. We said if not instance exists, koala, remember that, then move to the next room. Here we'll say if instance exists, follow whatever it is we're supposed to be following. Then let's update the position of the camera, and we'll do that by updating our custom X and Y values. We'll set our custom X value to be follows X, whatever the X position is of the player in our case. We'll set our custom Y value equal to follows Y coordinate, meaning our player's X and Y. So we're just basically we're going to move the camera here to wherever it is the player is. That's what this does. All right. The reason we're doing a custom X and Y is the following. We could just say X equals follow.x, Y equals follow.y, and it will just move in lockstep with the player, the camera will. But we want to do a kind of a visual effect in that what we want to have happen is we want the camera, if the camera is positioned sort of far away, relatively far away from the player, we want it to move quickly toward the player. If the camera is current position is close to the player, we want it to move a little bit slower. The visual effect will be this sort of quick move toward the player if the player's far away, and then sort of sliding into home, basically, slowly moving at the end until we have the camera's position and the player's position in the same location. And we can accomplish that by using these custom X and Y values. So we're going to now say, let's actually move the camera. So we're going to put the X plus equals, and watch how we do this. We're going to say X2 minus X divided by 15. So this is a little difficult to explain, but not so difficult. Here we're going to subtract whatever the value is here of the player. We're going to subtract from that the X position of the camera, and then divide that by 15, and then take that and position the camera using the result. So think about what this means. If the difference between the position of the player and the camera is really big, then when we divide it by 15, we'll get a relatively large number that we will use to update the position. If, however, the difference between the camera's current X position and where the player is really tiny, then we're going to get a really tiny number here, and so we won't move much, right? So the farther away we are, the larger move we'll make. The closer the two objects are, the smaller the movement will be. I'm lazy, so I'll copy that. And let's update the Y using Y2 minus Y divided by 15. Let's say what it is we're doing here. So we're going to update the camera position. And what are we doing up here? Update the destination. Where is it we're trying to move to? Great. What else do we need to do? Well, I said we want to have the player in the center of the camera view, okay? Or I should say the follow object, which is going to be the player for the most part in our case. So we want to keep the camera centered on the follow object. It's not quite right. What's the best way to say this? We want to we'll just call it that. We'll say we're going to keep the camera centered inside the room. Well, that's not exactly right. Okay. But how do we make that happen? Well, here we're updating the camera's position, right? And then we want to, in addition to that, position it so that it's sort of centered inside our current view. I know, confusing, but watch. We're going to use clamp. Clamp is going to take some values, and it's going to make sure that this x value is within the range that we pass it. So we're going to say, all right, x is going to clamp to x, then this view w, there it is, half. Remember, we just set that up a minute ago, plus buff, which was our buffer, which we set to 32. That's going to be what? Minimum value, okay? And then the room width minus view w half minus buff. This is super confusing. I understand that, but what we're doing essentially is let me explain this clamp a little more. We don't want to let the camera move visually outside the room. Okay, so imagine for a moment that here in our room we have this camera here, and it's following the player, and it's kind of centering the player inside the view of the camera, right? Well, if the player's in the middle of the room out here somewhere, that's no problem. But if the player's up against the wall here, what will happen if we don't clamp the camera to be inside the room is that this view will come way over here and you'll see outside the room. Or if the player goes way up and up and up, you'll see above the room. Or if the player is on here, even if they're just standing on this platform here, you would actually see down below the room. So what we're doing in effect is we're first setting the camera to follow the player. Fine. Then we are moving the view so that we don't get a view outside the room, left or right, top or bottom. And that's how we use clamp. Clamp will say we're going to set this first value, in our case the x and the y, somewhere between a minimum value and a maximum value. So we're not allowing the x or the y to be something bigger or smaller than these other two numbers. And in our case, the number that we don't want to let our x be smaller than is half the width of the room plus 32, right? Or the width of the room, how wide the room is, minus half the room minus buffer. It's just saying don't let us go outside the bounds of the room on the x coordinate. Let's copy and paste because I'm lazy. And let's clamp our y value in a similar manner. And now instead of the view w half, we want the view h half for the height plus buffer. And then instead of room width, we want room height minus view h half minus buffer. Ooh. All right. So all that is updating. It's a little weird. All of this is updating the camera object. Wait. All of this is updating the camera object, but the camera object's invisible, right? Yes, it is. So updating the camera object doesn't actually do anything. The player can't see it. The human can't actually see the X and Y position of the camera itself. It's got no sprite associated with it. So what we need to do is update the position of the view that that camera object is supposed to project. So as the last piece, we'll update camera view. And the way we do that is using a built-in function, camera set view POS. And what are we going to pass it? Which camera view we want to update. What's the X coordinate we want to follow. And we pass it the current X that we've just updated through all these zillion different updates, minus view W half. So whatever the X is, we're going to just move it around just to make sure the camera is right in the center of that view. Similarly, we'll do Y minus view H half. All right, this is by far the most sort of confusing bit of coding we've done so far. And if it doesn't make a whole lot of sense to you, I guess I would say for now, don't really worry about it. I explained it a bit, but the overall idea is we're going to move the camera bit by bit until it's centered over the player. We want to make sure we don't see the outside of the room, so we clamp the X and the Y, and then we move the view of the camera so that it is centered with the player right in the middle of the view. Ooh, boy. Okay, so with that long explanation in place, let's go into our room here, grab our camera, and let's place it out into the room. For this, I'm not going to create a new layer. I'll put the camera onto the player layer, and I'll put it up sort of, well, it actually does make a difference where I put it. If I put it way up here, it's going to rapidly move the camera view and slide it down so that it's centered on the player. So if I put it close to the player, it won't have quite such a dramatic zoom. All right, so here we are. Now we've got our zoomed in view at 1024 by 768. If I move along, you'll see now the camera begins to move with the player, keeping the player centered in the middle of the screen. As I come over and reach the right-hand side of the room, the camera stops moving, and it clamps so that I can't see outside the room. You'll see that I've got a little doorway here that we'll use in a little bit. All right. Again, I know it's a pretty confusing hunk of code, and I guess what I would say is even if at this point you're not entirely sure what's going on, you can implement the code that we've got inside this section of the project for our camera, and it will work. And then at your own leisure, you can sort of walk through carefully and try to understand how all this is functioning. All right, that's it for our camera.